Around IT in 256 seconds by Tomasz Nurkiewicz. Episode 71. Erlang.
Erlang is a programming language designed for highly scalable, fault-tolerant systems. Its primary use case used to be telecommunication, but these days it powers some of the biggest distributed systems. For example, 500 million WhatsApp users. The unique features of Erlang allow it to achieve amazing availability. A typical enterprise system may be unavailable for, let's say, a few hours per year. This means 99.9% availability. Systems written in Erlang may even reach so-called 9 nines. It means the system is unavailable for less than 31 milliseconds per year. How is that possible? Our typical application is written as a single process. It handles thousands of users or connections at the same time. In Erlang, each unique user, connection, or request typically spawns a new process. But processes in Erlang are very lightweight and dynamic. They consume as little as 1 kilobyte of memory. So it's common to create hundreds of thousands of them. Internally, Erlang runtime manages them within a single operating system process. So what's the big deal with these processes? Well, Erlang does not encourage defensive programming. It means programs should not try to recover from errors themselves. Instead, errors simply terminate a whole process. Wait, what? This actually makes sense. If you are implementing a telephony switch and your process fails, you lose one phone connection. Thousands of other concurrent connections are fine. But what if you build such software as a single monolithic application? Chances are a single failure cascades and brings down the whole server. That's unacceptable. Okay, so how does Erlang deal with errors? A process itself should not try to recover. Instead, processes are arranged in a supervision tree. When a process dies, its supervisor is notified and can react. It may ignore termination of one of its children, restart a broken child, or terminate itself, bringing down all siblings of the terminated child. Do you think this approach is naive? Quite the opposite. When was the last time you restarted the server because it was unstable or in some inconsistent state? We do it all the time. Turning something off and on again is a common strategy in our industry. Erlang processes are highly isolated from each other. So when one process goes down, restarting it may be the best approach. Oh, but by the way, how is the isolation achieved? Processes can't talk to each other directly. They can barely send asynchronous messages. Sharing memory or direct calls are impossible. Processes act as if they were deployed separately, even though typically they all live within the same Erlang virtual machine. However, you can easily deploy Erlang VM on multiple servers. Processes still talk to each other via message passing. So scaling out theoretically does not require any code changes. But wait, there's more. Erlang supports hot swapping of code. This means you can deploy a new version of your process without downtime. You can even have a new and old version working side by side. That's it. Thanks for listening. Bye.